My talk is about HERMES applied to HPC cluster purchases. Because I get asked a lot, how do we manage at EPFL these huge clusters purchases we made? So first of all, what is HERMES? Well, HERMES is the project management method of the Swiss Confederation, and it's the one that is used also by the financing audit. So it's really great to be audit compatible, because in case there are the auditors coming at EPFL, everything's clear. Even if they are not IT people, they understand what we're talking about. So it gives us a common ground for discussion. So first of all, I will talk about HERMES 5, because HERMES is in its fifth reincarnation, and we use the IT infrastructure scenario. So HERMES has several concepts. So we have the concept of phases, of tasks, of roles and results. So when you buy things or do whatever, you have activities that must be done. So for any activity, for all activity, there is a result. The results are documents that are produced within HERMES. So from the outside, what the people see is just the results, those documents. And also for any activity, for all activity, there's somebody doing that activity. So you match results and roles and activities. And this is all explained within HERMES. So HERMES, it doesn't solve all your problems. If you never bought a cluster and you think, oh, I'll use HERMES, it will tell me everything about how to buy a cluster. No, it just gives you a framework and a common ground so that everybody involved in the process of the purchase or in the controlling or whatever knows exactly what everybody's talking about. So common ground, common dictionary, that's all good. And well, as every method, it comes in a book. What you do at first is that you wonder if the book can apply to what you're doing. So you read the book, and the first question you ask yourself is the book stupid? So if the book's stupid, you just throw it away and you find something else. If the book is not stupid, well, you try to adapt what's in the book to what you're doing. You don't have to follow the book as if it was the pure truth. It's something that helps you. It shouldn't be an annoyance to the people doing the real work. And also the people who teach HERMES, they also say it, that if an activity is useless, you don't do it. So I was talking about phases. So a project has phases which are consecutive. It's completely linear, so don't worry, you don't have to multitask. Well, it's better if you do, but it's in a linear way. So you have first where's the pointer? There, okay. You have first an initialization phase, then a concept phase, then a realization, and then the deployment. At the end of each phase, there is a milestone. And that's very good because the milestone is something very official, and at the milestone, you have a result that should be signed by the people who have the power over the project. Here I put approximately how long it takes for every phase. So we have the initialization phase, it takes 4 months. And then we start the tough work, which takes 12 months. So now in detail, what do we do during initialization? Well, in very practice, very down to earth, there's an HPC steering committee that says, we need to buy something. So when they say we need to buy something, we need to talk to all the people that will be involved in the process. And it's very important to attribute the roles right away, so that we don't have surprises. We don't have to call in panic people at a certain point in the process by telling them, hey, I need you for 1 week to do stuff. No, we do the role attribution and the planning there so that everybody knows when the resources have to be allocated. So we also do a first survey about user requirements. It's a really vague survey. So we know the goal and the size of the cluster and the deadlines and the planning. For example, when we have some professors that have to spend money by a certain month because, well, they have funds or whatever, that gives us the deadlines. Then we do a technology survey. We see what processors are on the market. And this phase ends with an HPC committee, HPC steering committee mandate, where they say, well, we want approximately that, and that's all. So what's interesting about the initialization phase is that the HERMES specifications say that during the initialization phase, the specialist, so the guys actually doing the work, they can just be informed. So the initialization phase, it's just about the mandate expressing the needs. Now there's the concept phase. The concept phase, I think, is the most work-intensive phase in the whole process. So we have a detailed market study of what's available, an analysis of the present situation, and the detailed user's requirements. Then we infer the RAM quantity, the processor type, and the benchmark choice, which will also tell us the tests that will be run on the cluster during the realization phase. So practically everything that is to be done afterwards will be defined here. So now, how do we combine all these three things? Because they're not independent. So first of all, we go to the users, and we ask them, what do you want? And they tell us, as much RAM as possible, and the fastest processor that you can get. Then we do an analysis of the present situation, and we say, we gave you lots of RAM last time, and you did not use it. So we are not giving you as much RAM as possible this time, maybe next time. So you see, it's a ping pong between the user requirements, the analysis, and the market study. Now, about the processor choice, I would like to spend some time on what we do now to choose the processor. So for example, for the Bellatrix cluster, the one that was put in production beginning of this year, we asked Intel to be able to run a set of benchmarks on some nodes. So we had some prototypes, some Sandy Bridge prototype. Help. What's that? And we asked for a processor with three frequencies, so 1.8, 2.2, 2.6. And we chose some applications. So we have Quantum Espresso, is a software for atomic and electronic simulation. We have CPMD, Carpar in nanomolecular dynamics. GEAR is an astrophysics application. And MiniFE, it's finite element. So this should be approximately representative of what will run in the cluster at the end. And we run all those tests on the three processors. Well, of course, we ran also on AMD processors, and we saw that during the initialization phase that it was, well, Interlagos were not okay for those applications. So we just used Sandy Bridge in the last tests. So we run on those processors. And not only we measure the time to solution, but also the energy to solution. Because, as Thomas Schulte said, that's important to optimize for energy efficient, because we don't have an infinite amount of electricity, and that's too bad. So here I plotted the time to solution and the energy to solution. So we see that if we have the slow CPU, of course the time to solution is high. Then we go to the middle class one, and the time to solution drops down a lot. But if we go to the fastest one, it's not a big difference. How curious. And that's very evident for Quantum Espresso, which is, I think it's the type of application that runs most on Bellatrix, because it's a cluster that is used a lot for material sciences. Then CPMD, we have kind of the same pattern, and then GEAR and MiniFE, they look kind of the same. So we see big increase in performance here, small increase here. Let's look at the electricity. Of course, the lowest running processor uses less electricity. Then the middle one, it uses just a bit more. and then if you take the fast one, it just jumps up. And this is particularly clear for quantum espresso and less clear for the other ones. But still, we can see that this graph is very convincing in saying that the middle one, it's a really good trade-off. And also, there's a marketing implication. We cannot sell a cluster to users that runs at 1.8 gigahertz. Already I have remarks telling me, hey, why is the frequency so low? And then I have the graph here and tell them, it doesn't change a lot. Does anybody has an idea why it doesn't change a lot between 2.2 and 2.6? It's the same step, so it should increase, decrease like that one.
Memory access?
Memory, yeah. The bottleneck is the memory. So if the bottleneck is the memory, there's no need in increasing the CPU frequency.
You could add money to solution.
Yes, well, it's proportional to that one. But that's a good idea. We should add that at the end of at the epilogue, we should add how much the run cost. But I know that using Bellatrix for one night at 100%, it costs like 120 francs in electricity and cooling. I computed that after feeling guilty of having run HPL. So, at the end, the solution concept gives us a machine that it optimizes for our needs with respect to computing efficiency, but also power efficiency. So we can say we are green and everybody's happy because green is cool. Then after all this work about user requirement study, analysis of the benchmark, we write the specifications, we issue the call for bids, and before choosing the vendor, we negotiate. It's very important to negotiate before choosing the vendor, because when you have 4 that are in the run, you can just put them one against each other. You can just tell them, hey, the neighbor has a better price. If you want to win the bid, you have to make an effort. And I asked for help to the I asked the purchasing department of EPFL to help me with negotiation, because we have professionals in that, and it's always good to have a professional in the deal. And that was really great. We saved a lot. After that, we choose the winning bidder, and we had Intel going nuts because all the vendors that were on the shortlist called them and to lower the price of the CPU, and so they didn't understand what was happening, because apparently, well, it doesn't happen a lot that there are so strong negotiations before the choice of the winning bidder. After the vendor is chosen, we have another round of negotiation. Well, it doesn't work very well, this one, because anyway, they've won, so they have nothing to gain after they've been chosen. And after the negotiation, we write the contract. So the concept phase ends with a contract. The contract is signed by lots of important people in EPFL. When the contract is made, we wait for the machine to arrive on site. We have the on-site hardware installation, software installation, and then we run some tests. So we have the commissioning phase, where we run the benchmarks that we asked for in the specification. And we verify that the promised benchmark results can be reproducible on site. So that's very important to do. And who does that? Somebody from EPFL. HERMES says that the tests must be run by somebody from the client side, not the vendor side. It seems logic, but not everybody does that. So for me, it's important that you have somebody on the customer side to test what the vendor tried to sell you. Then we have the acceptance phase, which is just a stress test of the machine. And we use HPL and IO bench just to burn out the nodes that are too weak. So once the commissioning and acceptance phases are successfully passed, the machine is officially delivered to EPFL. User and service manuals are written, so they should be written in this phase. And the integration in the existing environment can begin. So when the machine is delivered, the deployment phase can start. So the system can be delivered to the users. And this should include documentation. Then we have the production start with a 2-week testing phase. Usually it's 2 weeks, but it depends on the schedule. And we do this test with a restricted number of groups to rule out some installation problems that we may have not ruled out during the testing phase. And afterwards, we open the machine to all users. And it's important not to panic, because that's a big thing. We have lots of users, and well, you have kind of a rush on the machine when you open up the machine. And finally, we have a big party where we wrap up the project and we free the resources that have been involved in the project. We didn't have a party for Bellatrix. Or if we did, I was not invited. Huh? Here are the details of the phases, but that's just a repeat of what was said before. So the purchaser says it's time to buy, so we do a first survey. It ends with a mandate, which should be signed. I made it signed the first time, second time I didn't, but it should be something that is approved by the purchaser. Then we do a detailed market study, detailed user requirement study, the solution concept, the test concept, that means choosing the benchmarks. We write the specification, and that leads to the call for bids. We evaluate the quotes, we do the negotiation, we choose the vendor, we redo a round of negotiation. And that leads to a contract, which is also signed. So you see, really at every milestone, there's something that is signed. Then we have the on-site installation with the tests, the reception, and we do some EPFL specific config and software installation, and the production starts. Now, I said that to do the actions, you need people. And in HERMES, that's represented by the roles. So you need at least 3 roles for any project. You need a purchaser, so a client. It's the one who has power of stopping the project at any time. So that's a really strong role. Then you have a project manager, and you have a specialist. What is very important, it seems logical after a while, but it's not for everybody, is that the purchaser must be a separate person from the project manager and the specialist. Project manager and the specialist could be the same person, but it's better not. In our case, you've understood it, that the purchaser is the HPC steering committee and its president. Then the project manager is me, the CSE coordinator, and the specialist is the operations unit at DIT, and in particular HPC DIT, and it was. Did I get the hair right, Fabien? One of my colleagues made remarks about the hair. So we have also additional roles that can be added to the method. We have several validators, because of course we cannot do such a large project. I mean, it's a big compute cluster, it pumps up electricity, it takes space, so we need to have some validators that tell us, inform us if the project is not feasible. So among the validators, for example, we have the data center manager, who's always informed about what goes on, because if there's no space in the server room, why buy a cluster? And also among the validators, we have somebody in the purchasing department who checks the legal validity of the tender, because it's very important that we are strict with legal issues. And since I'm not an expert in legal issue, I need some help from an expert in that. Then we have on the contractor, project manager is on the vendor side. When we decide who the vendor is, we need to have a unique point of entry from the vendor side. We also have a quality officer and testers. They work together. So the testers are the people who run the benchmarks on the machine at EPFL when the machine is delivered, and who are in charge of reproducing the results that the vendor promised in the quotes. So we have 2 testers. One is from the specialist side, from the ITAX, and one is from the user side. So they should be collaborating. And the quality officer is the one who controls that the tests are executed properly and who validates the results. And the quality officer is on the user side. And the result is a big machine. So now, at EPFL, we have different clusters for different usages. And you see that since ARIAS, it's pretty regular how we buy clusters. And also the naming is pretty regular. It's named A, B, C, D, with increasing the alphabet letter. It's like, I come from Fribourg, and they name cows that way. And it's a good way of differentiating the clusters and not mixing name up. So for each purchase, we have one project. So one cluster equal one project. And why do we have one purchase per year? Well, we have two reasons for that. The first reason is that we want to follow the technologies. And we have new technology approximately every 1 or 2 years. But we also need to follow users' needs. So sometimes the users want a big cluster with lots of nodes, but few cores per nodes, and InfiniBand. Sometimes they just want a cluster to run sequential computations. So we have those both criterion, technology survey and users' needs. So I'm done with the presentation. I would like to thank, buying a big cluster involves lots of people. And the HERMES project management method makes some order in that. If you want to use HERMES, you cannot work in autarky. You have to collaborate with other people. So it was really a great collaboration with lots of people. So I would like to thank the COPIL HPC, in particular the president of the COPIL HPC, who signed all the documents, all the milestones at the end of each phase. So that's very important, so that it's his responsibility, not mine. Then we have DIT HPC, especially Fabian Figueras, they do all the dirty work. So they're the ones doing the work and the ones I should not annoy excessively with all these project management things. And then we have HPC-ch, who wrote the specification, in particular Vincent Keller, who just left, who helped me a lot with the with the energy to solution metric. So it was really some innovation there. Then we have a benchmark dream team, people who give us the benchmark and give us very good explications on how to run the benchmarks, because the vendors, they will have to run it on their machines and they're not experts. So it's really hard work to put the benchmarks together so that they're runnable by anybody. And in particular, Simone De Paris, who supervised the benchmark dream team. Then I also asked Nina Stolzenberg from the purchasing department for some help, and she helped us save a lot of money during the negotiation phase. And Chiara Tanteri from the IT, who's very good with tenders. And then I would like to thank the vendors who played the game, so who played the HERMES game. So we have Intel, who gave us access to the platforms before they were out to the public. So you can contact Intel and they will give you access to test clusters, and that's very good. And Dell and Serviware, who also played the game. And this presentation could not have been done without Python, XKCD, and the Comic Sans font. Thank you.